Hello everyone. Now that we have an understanding of what a SuperTool is, let's have a look at an example. I've created a SuperTools folder in my own .katana directory, and inside there I have made an AttributeWedge folder that contains all of my Python files to build the SuperTool. Now before we look at the code, let's see this node in action. So we're going to jump over to Katana and I'll make a location create node and then make an AttributeWedge node. And let's view the parameters. So you have one for a self statement, and that's what locations you want to wedge attributes for. Next, we have a frame hold option that you can turn on or off. If you turn it on, it asks you what frame do you want to hold. Then you have the UI here. And finally, you have drop attributes here where you can drop attributes. So let's do that. Let's take this shading samples one, and we're going to middle mouse click and drag this over onto the drop attributes here. And this adds it in. And let's also add the root as our cell statement. And now I'm just going to hit spacebar to have a look at this. So the attribute that you drop in here gets listed in the first column. Next, it has what's your frame start, your frame end, and then the default value. So if it's outside of this frame range, what value should it be? And that will just grab what the initial value is that you dropped. Then the initial value, so what value it will be at the frame start, operation it will do, and then the wedge value. So you can either add or multiply. So currently right now it's set to add, so it's going to start at 1 at frame 1 and keep adding 1 until it gets to frame 11. So let's see that in action. So you can see currently I'm on frame 1 and it's 1. And as I move along, changes 2, 3, 4, etc. We get to 11 and change to 12, and it changes to the default value of 64. Let's add another one. So to the pixel samples, for example. And I'm going to say the frame start of this one. So I want to wedge this after a previous one, and I'm going to wedge it for 20 frames. And let's set the initial value as 5, and let's change it to multiply. We'll multiply by 2. You can see now on this one, it's 5 for its first frame start, and then as we wedge across, it's doubling and doubling, getting huge. Then 32 is the last one, and it goes back to the default value of 9. So now we've got 2 wedges going on. That's pretty good. So what you'd do is you'd, run out your wedge. Say you've frame held like the action, and this is like the frame you want to look at. You run your render, and you can say to your supervisor, okay, these are all the different values. Do you want to pick your favorite one? Job done. Everyone's happy. Okay, so let's have a look at what's going on under the hood. So we start off with our init.py. What this will do is import your version. So we've only got version 1 at the moment, and it will name it as your SuperTool name. And then if it exists, then we're going to register it, and we're going to register it as a SuperTool. And if your Katana version is 2 or greater, then it will add it to the list. The name of it is going to be AttributeWedge. And then you have this AttributeWedge node and get editor that you set inside the versions init.py. So if we go here, we can see that the AttributeWedge node is imported from our node.py. And we have a get editor function that's importing the AttributeWedge editor that it gets from the editor.py. It's all pretty straightforward. We also have the upgrade.py, which I have just left exactly the same as what we had in the pony stack, because I only have 1 version, so I don't need to currently do any updates if the version is out of date. Next, we have the script actions, and this just has 2 functions. One is to get the reference node, so you give it a node and a key, and it will get that parameter and from that parameter, it will get the node and return it. And the other one is to add a reference parameter to your node. So this will link a node in your parameters so you can get it easily. This script actions.py is basically a place to put any utils that you know are going to be shared between the node.py and the editor.py files. So functions that you know are going to be for both building a UI and for the internal structure. And then we just have our main nodes, so the editor.py and the node.py. So I'm going to open both of these and we'll run through them. So let's first of all hide this sidebar. So we've got a little bit more room. And we'll start off with the node.py. So import in login and an ordered dictionary to use. And then we've got the utils, so we can do the undo stack, and the node graph API, so we can build our nodes, etc. And we'll import the upgrade, so we can upgrade our nodes. And we'll have our script actions as well that we can share between the node.py and the editor.py. And we're going to say add to the logger that we're now using the AttributeWedge.node. And then I've got a couple of global variables here. So one is just attribute types. So whenever you drop an attribute here, it will grab hold of the attribute type. And then inside my AttributeWedge node, I am creating attribute set nodes. And if I want to set what type of attribute it is, it will be an integer, a double, or a float. So this is just an easy way of transferring what attribute type it is to what the parameter name should be for that attribute set node. And then I'm also getting the in time from the root node so that I can use that. So when you add an attribute in here, the initial start frame can be your in time, so that it's a little bit more user friendly. Okay, and then we have our class, which is an AttributeWedge node, and it's using the SuperTool class. We have the initialization, so it'll build the initial parameters. The first thing it will do is hide the group controls. We don't want this to look like a group, we want it to look like a regular node, so we turn off those controls. Next, we add in the input port and output port. And so we have in and out, make it all about. And then we grab hold of the root parameter so we can add all of our parameters to it as children. So we add in the version, the cell, the frame hold, and frame to hold. Now you notice that there is no version in here, and that's because everything that you create as a parameter will also need to be added in the editor as part of the UI. And you can have some parameters that you add that don't actually get shown in the UI, but they're stored in the node. And the version is one thing that we're going to keep hidden. And there'll be some other parameters that we'll add that will be our reference parameters that will also be hidden from the user. Okay. Next, what we're going to do is build the internal network for our node using this build default network. And what this will do is create all the nodes inside. So let's go inside here. And I've just set some spacing for Y and X. I'm going to create a dot node first, and I'm going to connect it to the send port. Then we've got a time offset node. And if we go to the time offset node, you'll see that the input frame is an expression that is linked to the frame to hold on our parent node. So that's set to it here with an expression. And then I'm connecting it to the dot node. Next, I'm creating a switch node, and I'm connecting the time offset node to input 1 and the dot node to input 0. So I'm also just adding them here as 0 and 1, and also making this as an expression to get the frame hold. So go here, and we're going equals up, get the frame hold. Okay. And then lastly, we have our group stack node. This contains our attribute sets that we've made here. So what I'll do is add the child type of attribute set, so that all we need to do is create a child of this and it will automatically be an attribute set. And the handy thing about using a group stack node is that it will handle all the things of like piping it all in, connecting it and all that. All we need to do is just add a child or remove a child. And then finally, we're going to connect the group stack node to the return port. And that's it. Okay, so let's now jump over to the editor's initialization. So what this will do is run the upgrade to see if it needs to be updated. Next, it will have a couple of variables set on it. One is, we'll set it first of all as frozen is true, and shall update the table and idle as false to start with. Next, we're going to grab hold of the parameter widget factory. So this widget factory is what you use to build parameters for the UI. Then I'm going to have a list of all of the parameters I want to add. And I'm going to create a group policy data that's going to have all of my parameters. And this just gives you the order of those parameters. And then I'm going to make a group policy using the form master -value policy and set it as my group and give it the policy data that I've made. And then I'm going to use the widget hints to hide the title, so it won't display it. It will just hold all of my parameters inside. Now, the reason why I want to use a group parameter to put all of my parameters inside is that I'm using a conditional visibility on my node on my parameter to display the frame to hold option. So it only displays that if the frame hold is active. And you can only do that if your parameters are relative to each other, because if we look back on the node.py at the bottom here, there's a function that runs which is called add parameter hints, and this will automatically be added, and it will cycle through all of our hints and add them to the parameter. And you know, got a widget type of cell for my cell, and then a widget type of checkbox for the frame hold. And then for the frame to hold, I've set some conditional visibility options, and the path of that is a relative path, which says, you know, get the frame hold from where I'm at. Now, if we don't make them inside a group value policy, then they won't have anything relative to each other. And even if I've set this to use conditional visibility, it won't work. Okay, so now what we're going to do is we're going to cycle through our parameters and add the parameter policy to each of these, and then add that to the group policy. And then once I've added all of those, I can then build the widget using the widget factory, and that will give us back the widget, and then we can add that to the layout. And that gives us these ones. We've got a cell, our frame hold and frame to hold. Next, we're going to build the table widget. So we're going to use the Qt widgets QTable widget. So this is just trying to show you an example of using PyQt. There are some widgets that are available from Katana, but you can make anything you want. So I thought I would do a table as an example for this. And then I'm going to set the column count to 7 and set all of the columns. Next, I'm just going to set some behavior for the table to say how it should be displayed. And I'm going to have it so that when you do a key press event, it will run this function. And I'm going to add my table to the layout. And then next, I'm going to use the UI4 widgets. And there's a whole bunch of different widgets that you can get from Katana's internal widgets. One of them is this attribute drop label. So that's adding this here. And then if an attribute is dropped, it's going to run this add attribute function. And then I'm adding that widget to the layout. And then lastly, I'm going to run this update table contents. And what this will do is add any attributes that have been added to the attribute set group stack. Now, the reason why you'd want to have it so there's always something that's running that adds, builds our UI is if I were to create all of these, adding these in, and then save my scene and close it and then open it up again, you want it to be able to then rebuild the UI. That's why you need this sort of update table contents to always have something that is building the UI each time. Okay, and then lastly, I'm adding a stretch. It's just so that these will get stretched out. Okay. So let's now look at what happens when you add an attribute. So that's going to run this when you drop something on here. It's going to run this function, add attribute. And the function gives you the attribute and its name. So first of all, from the attribute, we're going to get its type and check it. So if it's an integer attribute, double attribute, or float attribute, then we're good to go and we can wedge that. Next, it checks how many values are in that attribute. And if it's 1, it's good. If it's got more than 1, it won't. Then it's going to get the value and it's going to run the add attribute node function from our node.py. And if it gets created, then it's going to set the update table and idle to true. And then it has a bunch of else's. So if this comes back as it's not created, that means we've already added the attribute and you'll have the message attribute already added. If it has more than one value, then it says only attributes with one value can be accepted. And if it's something that isn't one of these type of attributes, then it'll say only numbers can be wedged. So let's see that as an example. So this is a group attribute. I drop that in here. There's only numbers can be wedged. If I were to drop something that's a string, it'll say only numbers can be wedged. If I drop in an attribute that's already been wedged, it says attribute already added. Okay. And you can see that these are all queue message boxes with a warning, and it will display the message that has been saved here. Okay. So let's have a look on the node.py side to see what happens with the add attribute. So here's add attribute node. So this is first of all saying created equals false. So we don't know if it's going to be created yet or not. And then it's taking the name and changing all of the dots to underscores, because you can't have a parameter name with dots, because that's the divider for each of the levels in parameters. So yeah, we're going to swap that to underscores. And then we're going to get the parameter. So if this comes back as existing, then we know we've already added this attribute as a parameter to our node. So therefore, we don't want to continue. We want to come back and say, oh, this has already been added. Okay, we'll see how that gets set up in a minute. So now created equals true. We're going to create this, and we're going to open up our undo stack to say that we're adding the node, and we're going to try and add the node. So first things first is we're going to get the reference node of our group stack, and that will return a group stack node. And then we're going to build a child node. So that's going to create an attribute set inside of our group node. And then we're going to add a reference parameter to our top level node to link it to the attribute set node. And then that's what we'll use later on to check to see if it already exists. Next, we're going to set all of the parameters on our attribute. So, the mode, we'll set that to a cell statement, and then we'll link the cell statement to the cell statement that's on the main node. And we'll set the expression flag to true. We'll set the attribute name to the name given, so this. And the attribute type, we'll set the value based on attribute type that we've got, and we'll look up our attribute types dictionary to find out what it should be called. And then we're going to add all of these these columns in. So we're going to add in the frame start, frame end, default value, initial value, the operation, and wedge value. And then we're going to use all of these to create the number value as an expression. So if we actually go inside our attribute wedge, look at our group stack, choose one of these attribute sets, we can see it's added the frame start, frame end, default value, the initial value, the operation, and the wedge value. And then it's going to create an expression on the number value. We drop this down, here's our expression. And all that's doing is saying, if the operation is add, then it's going to do this, and it's going to take the initial value and then add that to the difference between the current frame and the frame start and multiply that by the wedge value. Otherwise, it's going to take the initial value and times that by the wedge value to the power of the current frame minus frame start. If the frame start and the current frame is in between the frame start and the frame end, otherwise default value. So it's pretty straightforward. And then we're going to set the expression to true, and that's it. And then finally, we'll just close the group and return created. Okay. And you remember that we did this update table and idle equals true. Now, what happens when we do that? Well, there's these show event, hide events. And what this will do is if you're viewing the parameters for our SuperTool, then it will start setting up all of the listeners. So it will do a show event and say self.for, and it will run the for, and this will set up the event handlers as true. And if you're not viewing the parameters for the node, then it will set it to being frozen, and it will freeze, and it will turn off all the event handlers. These freeze and thaw functions are so that you make sure that your event listeners are only happening while you're viewing your node. You don't want these to be just running all the time. So this allows it just to turn on these whenever they're needed. And then for the event handlers, I've set up two event handlers. One is an idle event handler, and one is a no delete begin event handler. So if it's an event idle, it will run this idle callback. And if it's a node that is being deleted, it will run this delete node callback. Let's have a look at the idle one first. So this is where you have this update table and idle. If it's true, then it will run the update table contents. And this is where it builds the UI. Now, the reason why we use this idle callback to build the UI is so that we can call it anytime and build the entire UI from scratch. Now, this is important because you can't just build your UI as you go, because if you were to then close down Katana and open up again, your UI wouldn't be built. You need to have this idle callback so that it's always going to reconstruct it when it's needed. And what happens is you run it, and then after that you set the variable to be false so that it doesn't then run again. And then anywhere in your code when you need to refresh your UI, you set it back to true again. Then the idle, when nothing's happening, the idle callback will be run and it will refresh everything again. So what it will do is, first of all, you have a maximum for all of these different spin boxes. I've set to 9,999,999. You can set it to wherever you want. Next, I'm setting the table widget to say that there's no rows. So that's basically clearing all of the rows. So there's no values. It's just got the headers. Next, I'm running this get all attributes from my node, and that will give me a dictionary of all the attributes, which we'll look at in a minute. So now we have a dictionary of all of our attributes and their values. We're going to cycle through them, and we're going to have the name of the attribute and its values, and then we're going to grab each of these. So this is basically just getting all of these values here. And then we're going to get the row count. So this is basically our iterator. And then we're going to first of all create a table widget item with the attribute name. And we're going to set it so that you cannot edit it, but it is selectable. So it allows us to be able to select these, but we can't edit them. Makes sense because we want people to just drag in the attribute and list it here. We don't want people to manually type it in because that creates mistakes. Okay, then we're going to set the row count to +1. So we add in a new row, and the first item is going to be our attribute. Next, we're going to add a spin box. We're going to set the minimum maximum, and we're going to set the value as frame start. And we're going to add the cell widget to the table, and we're going to connect a function so that if the value is changed, it will update the attribute. And then this is basically the same thing again and again. So same for the end frame. And for the initial and wedge values, what we're going to do, and the default values, is we're going to check first of all the attribute type is. If it's an integer, then we're just going to use an integer spin box. If it's not, then we're going to use a double spin box. So we use a double spin box for if it's a double or a float. And if it is a double one, then we're going to set the decimal point to 4. You can change this to something different if you wanted to. And then we're just going to build each of these. So default value, initial value, and they're going to have the same update attribute function. And we're just literally just adding it with the row count and its column value. Okay, we also got the spin box, the combo box for our choice of operation between add and multiply. And we're just going to set the current text as whatever the operation is currently, and then add that widget, and also do an update attribute if that changes. And then there's our wedge one, and that's it. And then we're going to resize the columns to contents once it's been added in, so everything all fits. Okay. So let's now have a look at the, see, this kind of have to jump around quite a lot when you're doing this. The node function that we ran to get all of the attributes. So this one here. So we're going to jump back over here. Get all attributes. And this is where we use the ordered dictionary. And we're going to get our group stack node and then get all the child nodes. And then for each one of those nodes, we're going to get the parameters that we've added to that are the default that you get with an attribute set, and just make sure that they do exist. And then we're going to get all of the values from that and store it inside the dictionary, and then return that dictionary. So that's all pretty straightforward. So we're going to see this update attribute, see what happens when it runs. So it's actually quite a short one. What it does is it gets the attribute name, and then it runs the update expression on the node. So there's a function on our node.py that takes these values. So let's pop back over here, and we have the update expression. And all that does is get the attribute set node, and then from there, if the column is any of these values, then it will change the parameter to the value that comes in. It's pretty straightforward. Okay, and then we have a few little extra things So we have an event listener for if we key press on this, and that is only going to do anything if you hit delete. So if you hit the delete key, it will delete the attribute from the list. And we can see that in action from the delete attribute. So what that will do is get the attribute name and then run the delete attribute node from our node Python file, and then set the update table on idle to true, so it will rebuild everything. And the delete attribute node is just again getting the parameter name by replacing the dot with underscore, get the group stack node, get the attribute set node from the reference, and deleting the child node of the attribute set node from the group stack node, and then deleting the parameter. Okay. And if we have a look at the delete node listener, so what that does is it just gets the args and finds out what has happened for when it's been deleted. So it will get the parent, so that will be the group stack node, and if the group stack node's parent is the SuperTool, then we'll run update table and idle. Okay. And then we also have the right click context menu. That's at the bottom here. So I've added a context menu. If you right click, it will give you this action of delete, and then it will run the delete attribute function. That allows us to also delete attributes. Okay. And that's it. There's all the different steps for it. It's kind of a little bit fiddly. You have to think about how you interact between the editor and the node. But you can build pretty much anything with this and create really powerful super tools. So have fun.